Hello and welcome back to day 3 of Advent of Code 2023 in Clojure. Let's hop right in. Day 3, gear ratios. That already sounds annoying. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water sewers, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. You turn around so you see a slightly greasy elf with a wrench and a look of surprise.
Sorry, I wasn't expecting anyone. The gondola lift isn't...
Okay, I'm not going to do voices. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here is an example engine schematic. In this schematic, two numbers are not part numbers because they are not adjacent to a symbol. 114 top right. And so... Sorry, 114 and 58 middle right here. Every other number is adjacent to a symbol and so is a part number. The sum is 4361. Of course, the actual number schematic is much larger. What is the sum of all of the part numbers in the engine schematic? Okay. So these are the whole numbers. Okay. So is this is like 467, right? Not 4, 6, and 7. Yeah. So it's always the whole number. Dots don't count. And this is adjacent to a star here. Diagonally, this is adjacent to a star here. Here, here. This one is not. This one is diagonal. This one is with here. This one is with here. This one is with here. Okay. Boah. I think this is gonna be tricky. I'm not quite sure yet how to do that. Okay. Okay. I'm thinking, well, we obviously have to like look around a single digit, but it's not just a single digit, we have to look around the whole number. Like we need to treat this as a whole number and look around it. I think digit obviously would be simpler, but like it feels like we have to load the input into an array of arrays and then go through the whole thing. And when we're at one, look around. But that's obviously gonna be not that easy. So maybe we can do something else. Maybe we can actually only always look at above, below, like go through if we load this into, like, if we make this a map like 1, 2, 3, 4, 5, then find the digits within each So if we find the numbers within each, and then figure out where we need to look for that. Boy. I don't know where to get started with this. This is gonna be really interesting. Okay. So let's grab our example input and write a test. $4,361. Example all part numbers engine. So I'm gonna need a REPL. Gonna load this, gonna load that, gonna import actually our namespace. Day 3 part 1 as part 1. Gonna execute the tests and it fails. Okay. Test def test returns 0 when no part, is it called part number? Well, just when number is next to, when number is not next to symbol. Equal is equal 0 part 1 sum of all part numbers if we just have a 1. So we can make that pass by doing that. Okay, that's not very helpful yet. Def test returns 1 when 1 is right of symbol. So this should return 1 if it is right of a symbol, so a plus, for example. All right. So we need to somehow so anywhere where we have more than one digit, oh, we don't need a group here, do we? The problem is this doesn't tell us anything about where it is within the string. Is there a way to... no. Index of takes where we're looking within. So this, and then for example 1, 2, 3. So 5 would be the index here. 0, 1, 2, 3, 4, 5. Okay. So if we find all numbers and then map them against their index and map them against which line they're on, then we would know the start of every number, or not even just the start, the coordinates of the start of every number. So what I'm thinking is so something like def n index numbers takes a line. We find all of the numbers. Let all numbers, oops, these against line. And then we return map indexed. Oh, we don't need a map indexed here, do we? Map number return string index of how do we want to structure this? I feel like a map, but I'm really not sure. How does map index work again? Function index and item. So if we have line index and the line here, then what I want to return here is a list. So a map here where number is number. We need like let's try to do it in line. Basically what I want to get to is I want to have the number and I want to have all of the neighbors of the number. That's what I would like. So map fn number let number index be string / index of number in the line. So we can do index is line index number index, something along those lines. Along those lines. Hilarious. So if we would do that for map indexed index numbers of this doing something wrong. Map, oh, we need to map here over all numbers. So number 1 is at index 0, 1. Number 1, 2, 3 is at index 0, 5. That's not too bad. So now we need to calculate the neighbors. I know I'm trying to solve a lot of this stuff without actually making my test pass, but what can you do? So neighbor index. So the neighbor index would be def in calculate neighbor. So that would need x, y length, xy length. I would like to somehow get to this passing, to be honest, but I need the neighbors. If I leave out the length for now, I can somehow make this work, can't I? So if I say the neighbors are... Oh, this is always the tricky one where you have... -1, -1. So if there's like an x and a y-axis, then you need to get -1, -1, -1, same, -1, +1. Actually, I think we can do like a range of, oh, it's gonna make my brain hurt. This is gonna make my brain hurt. What is X and what is Y? This is X, right? And this is Y. Or should we say index nth line? Line and then index. So line, index, number, index. I think I like the better. Line, index, number, index. Okay. So if we do from range 0, 1, what does that return? That will return 0. So if we have something at basically what I'm trying to figure out is if we have something like dot 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 x dot 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 dot. So if we're talking about like a number here, if we're talking about this one, I want to get this, this, this. So 0, 1, 2 is what I would need. So if it is at 1, so if number index is 1, then I need a range from decrement the number index to this is not going to be enough, is it? This is going to give me 0, 1, but I need 0, 1, 2. So it's going to be increment and the length is 1. So plus 2. So it's increment plus length, where length here is 1. So that will give me 0, 1, 2. And I can do that for line index minus 1 and line index plus 1. So I can map, if we have line index 1 here, map, so then we have let we already have a let, we can use this one. One up is map no, this is number index. Number index, number index, number index, line index, decrement, line index. And we do that over that range. So that would be the up, like up down range. It's a bad name. So, but one up. And it will be 0, 0, 0, 1, 0, 2. Okay. And then 1 down is the same thing, but we increment the line index. And it will give us concat 1 up, 1 down. Zero, 0, 1, 0, 2, 0, and then 0, 2, 1, 2, 2, 2. So it's these and these. And then the last thing we need is the number neighbors. So this is actually like, the number neighbors are relatively simple. They are just a list of line index and number index minus 1. So it would be 0, 1, yeah, that would be this one. And then the second entry for line index, and number index, got that wrong here. Number index of plus number index length. So now if we make this wider and say this is our number, so that would be the number index is 1, the line index is 1, the length is 2. If we calculate that, we should get on line 0, 0, 1, 2, 3. On line 1, 0, 1, 2, and 3. And then on line 2, 0, 1, 2, 3. Yep, I think that will work. So that is previous line neighbors. And those are next line neighbors. And that is the neighbor range. Previous line neighbors, next line neighbors. So now we all need to stick that into a function. So line index we can get rid of, number index we can get rid of. So should we change this to line index, number index number index. And then neighbors is calculate neighbors, and then we break that. So line number length, neighbor index, line index, number index length, where length is count number. So index numbers, line index and line. So actually map indexed index numbers of string / split lines engine schematics. If we run this and we run that, we have the number 1, line index 0, number index 0, and then we have neighbors, and we should have 1, 2, 3, 4, 5, 6, 7, 8 neighbors. That make 8 neighbors. That makes sense. 1, 2, 3. It would be like this. 3, 6, 8 neighbors. Yeah. So that makes sense. So we have 8 neighbors, and now we need to find if let indexed numbers be this. I want to move this whole thing into a function. And then I want to call this index line. So index numbers, engine schematics, and then I want to index the schematics, and that one is a bit uglier. Def and index schematics. So we are gonna do a map def and schematics line index line map indexed. Actually, so basically what I want to end up with here is I would like to have an array that would say like 0, 0, and then that has the character dot, for example, in it. And then 1 has a dot, and 2 has a dot, and that's line 0. And then we have another entry here, which is line 1. And then we have the 0, and etc. So if we do a map, we can basically then just like use all of our index numbers and just look at the neighbors in the indexed schematics and see if any of them are a symbol. That's what I want to get to. So I think what we need to return here is a line index and then a map into a map. This would be the number index. Oh wait, can I do, does this work? Into a map indexed, I can't do identity. Oh, it's not number, this is character index character. This is my function. This is what I'm indexing. This is what I'm getting back. 0, 1, 1, 2, 2, 3, 3, 4. Oh, I feel like there should be a smarter way of doing this. I really think there is a better function for that. So if we do that, and we do an into map indexed index schematics line over engine schematics, again string / split lines engine schematics index schematics 1, 2, 3 \n 4, 5, 6 0, 0, 1, 1, 2, 2, 3 1, 0, 4. Well, at least that works, but I feel like there should be a better way of doing it. Index schematic, this is indexed schematics, index schematics engine schema. And then we need to filter all the indexed numbers where we find if def n symbol neighbor and that is gonna need the engine, the indexed schematics and all the neighbors, which is gonna be a list of a map. Is it a list of a map? I've already forgot. Print line index numbers. So the neighbors are a list with number index line index. Okay, so symbol neighbor would be keys number index line index, and then we say get in indexed schematics line index needs a number index. Is that doing something dumb, are I? Yeah. I'm in the parameter list. So. And it is a neighbor if not using a set a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 0 or a dot. I'm really worried about using like stars and pounds and pluses and dollars because what if the input is like slashes and carets and whatever? So I really want to just say everything that's not a dot or a digit, that's a neighbor. And then what we're gonna do is we're gonna say has like any symbol neighbors. And what that's going to take is going to take the indexed schematics and a single number. And as we see, a number here has a line index, a number index, and its neighbors. Does it need to go out? All right, dog time. Okay. So that is for neighbors. And then we say any. Wait, that's the wrong any again, isn't it? Some. No. Is it like the filter first thing in Clojure, which is always a bit weird. First filter some partial indexed schematics symbol neighbors. So indexed. So we have all of this and with the indexed schematics, and then if we print line. I just realized that this is a list of lists. Maybe this doesn't quite work. Dot 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 1. What does this return? From here to it's hard to read. Clojure pprint. Wrong number of arguments passed. Index numbers. Wait, no, that's fine. Index schematics. What is going on? Indexed. Oh, did I? No, indexed numbers. Print line indexed numbers. Print line indexed schematics. Where What's 1, 3? Oh, what is this? Delete all of it, right? So, indexed. Why is this a list of lists? Indexed numbers is a list of lists, which is what I don't want. There we go, that's better. Number one. Line index 01. What? No. That is weird. Oh, what is this? Number index. Because I have 2 1s now. That is super annoying because it's gonna find the first one. Like this way it would work. Is this gonna become a problem? Do we think we have the same number twice within... Do we have the same number twice within the same line? Could be. Then we're screwed. Okay, for the input that we have, let's see if we can make it work. So, any symbol neighbors for indexed schematics and neighbor. Nil. Nil. Number index 0, line index -1. I mean, yeah. But why does it then... Is the problem there first? My brain. Does anything... an exception I would see. Get in index schematics. Let's see this. See. Something ain't right. So these are all of the neighbors. These are all of the neighbors. 0 minus 1, 1 minus 1, 2 minus 1, 0, 0, 0, 2, 1, blah, 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 blah. Okay. So what do we get for index schematics here? Zero. Okay. So that makes sense, and neighbors looks correct as well. So why? Hold on. That is the wrong way around. Partial symbol neighbors. Horrible. Partial symbol neighbors index schematics. Haha. Nil, nil, nil. Nil, 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 nil. There's a plus here. So. Nil, nil, nil. So for what is the first index number here? Print line first indexed numbers. Sum of all parts. This is the first one. It's number 1. And these are all of the neighbors. But then why 2 minus 1? Line index minus 1, number 0. Okay, hold on, I'm getting confused with what I'm printing. Oh, because I'm... No. So sum of all parts. This is the first index number, the number 1 on 0, 1 with all of these neighbors. So we pass the neighbors into any symbol neighbors with the index schematics. This is going to do the filter, that's going to run through here. So we're going to run through 0, minus 1, oh, nil. So it's when C. There we go. Zero, 1, nil is nil, blah, blah, blah. True. False. I guess I can just stick a nil in there, can't I? So on the line index, this is like so confusing. Doing something wrong. Nil is true, nil is true, nil is true. Nil is false, nil is false, nil is false. But then why does it stop there? What is with the rest of the neighbors? Oh, does it crash? Okay. So, okay, I feel like it, no. I don't know. Eight neighbors here. There's not an exception. That's good at least. Zero, zero plus is true. So if this returns true, it should stay in there and it should return it. Oh, I guess it does. Oh, it returns the neighbor first. Does it just work? And I've been being dumb. False, true. Okay. Maybe this just works. So what we want to do is then numbers with neighbors is filter partial any symbol neighbors of indexed numbers over indexed numbers. Schematics, of course. Then we print line the numbers with neighbors, and we also return the numbers with neighbors. Why? Nil, nil. Oh, hold on. Any symbol neighbors over. This is not the numbers we need to do. keys neighbors. Just getting a whole number here. There we go. So number 1 has 1. So then what we do is we do a reduce arc number plus arc number over 0. I don't need 0 right at first. We can just say numbers with neighbors. One. Okay. No failures. Let's see. If our input has 2 of the same numbers in the same row, then we're screwed. Day 3, new file input text. Slurp. Day input text. Oh. That is not good. Dot slash source underscore day 3. Did I not? Okay. Oh, there we go. Please be right. Too low. I assume somewhere we have yeah, I don't know how I would even find that, to be honest. Don't know if it's worth staring at that. All right. Returns 1 when only 1 is next two symbols. So if we do this dot this, then this should return 1, but it's going to return 2. Oh wait, but wouldn't then our number be too high? No, not necessarily. Right, not necessarily. If we do like this, it's going to return 0. Yeah. Oh, index line. If we make this a reduce, if we make this indexed numbers number, let previously, like same number is last typing filter number in is number parse long number over index numbers, and then search index is if same number, then plus number same number, or should we do like last index is plus number index count number. And let me just say if same number, then we take the last index of same number, otherwise we just search from 0 onwards. And then we pass the search index here. Zero one, still 0, okay. Print same number. Oh wait, and this needs to change now, because what we need to return here is conj indexed numbers. This one. Crash. Because we need a cool. Is that more or less than before? 539, 356. Ugh. 539. Well, maybe. Oh. Paste the right number. 539, 356. I'm not gonna finish this today. That's what it is. I found the issue, and it's not fun. So the problem was that if I had a number like this, 33, 6, 33, then the way I did my matching, here to find the numbers index was based on string index of, and I already found that there was a problem if I had the same number twice, which is why I had this one here. But of course it's also a problem if you have like partial matches. So what I did is I rewrote the parsing of the lines to not just do an RE sequence, but also do an RE find on a matcher. Because what you can do on a match then is you can call .start on it, which will actually give you the index. And I basically use this to immediately use regex to find and give me the indexes of a single line, and then I don't have to do all of this stuff anymore. All of this becomes way simpler. I can just grab the index that we passed previously. Yeah. So I grabbed the result here, and that actually worked. So very, very annoying. But let's see if part 2 is as horrible. Part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Unfortunately, the gondola has a phone labeled help. Fortunately, the gondola has a phone labeled help. So you pick it up and the engineer answers. Before you can explain the situation, he suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. This time you need to find the gear ratio of every gear and add them all up so that the engineer can find out which gear needs to be replaced. Consider the same engine schematics again. There are 2 gears. The first is in the top left, so this one with that one I assume. The second gear is in the lower right. Its gear ratio is lower right. This one times that one, right? The star adjacent to 617 is not a gear because it's only adjacent to one number. This one, yeah. What is the sum of all of the gear ratios in your engine schematics? Well, the way we're passing this right now doesn't work at all. So, yay. Okay. We already have all of our numbers indexed and we already know all of the neighbors. So we find all of the stars, look through all of the index numbers, find all of them that are next to a star through the index of the neighbor, and then see if there are 2, and if there are 2 we take the numbers and we add them up. Okay, so I am annoyed by this day so much. So part 2 test. part 2 test, part 2 is part 2. Get rid of this, I don't care. Is this the same input still? Yes, it is. Sum of all gear ratios, sum of all gear ratios. The sum is this, that, then we copy part 1 into part 2, add part 2, so now move this over here. Okay, and we have all of the index numbers and we have the index schematics. So what we're going to do now is indexed gears. Indexed gears is filter. I don't know. Can we quickly extract it from the indexed schematics? I think we can. The indexed schematics look like this. But I would want to like put that on its head, right? I would want to find all of the stars. So I'm wondering if it's easier to quickly rewrite or copy and paste and modify the index in logic, or if it's easier to put this on its head. So indexed not schematics, gears, index gears takes indexed schematics, and we're gonna do a reduce function gears and it's gonna get a line over empty and indexed. So my yeah, no, uneven number, it's fine. So like this index gears so that goes 0 is the 1 0 dot so that means this is the line index and these are the, I don't know what to call them, parts, I don't know, character, I have no clue. So line index character. Oh, we need to return always the updated gears. So, okay, so we have those, and then we need to say one is a dot, for example. Okay. So, oh, actually, this is the line index to all, I don't know, indexed characters. And what I want to do now is I want to filter fn. Don't care about this. I care about the character equal backslash star character over all indexed characters. Let gears print line gears. So those are all of the gears, and then what we're gonna do is we're gonna concat gears with map fn. Now we can ignore the second part, so we just want the gear index and ignore this. Well, we don't need to do that then, right? Oh, we can just do first, can't we? And what I want to return is line index gear index over all of the gears. Oh no. Line gears. Zero, zero. Okay. Yep. So these are now all of the indexed gears over indexed schematics. Now I want to print them. And I want to see if that looks right here. So we have found 3 gears, step 1, line 1, 3, yep. 4, 5 lines 0, 1, 2, 3, 4, yep. And then 5, 6, 7, 8, yep. 0, 1, 2, 3, 4, 5. Okay, so we found all of them. So that's good. Def in calculate gear ratio. That is gonna get indexed numbers and a gear, where a gear has a line index and a gear index. Then the only lines we always have to look for are the one above and the one below. So I know it's a bit of an optimization, but I think it might be worth it. So lines to search are select keys of indexed numbers, and our keys are decrement the line index, and increment the line index. Lines to search. This fails. Find not supported on type lazy sequence. Oh, the index numbers don't look like that. The index numbers are just a huge list. They don't look like the index schematics where it's just X, Y, and then the thing. So that is actually lines to search would be filter. That is annoying. Fn keys line index were deck line index number line index inc line index of number, and we filter over indexed numbers. So so we should get I see a line index -1 here. Oh, because it's the neighbors. Yeah, okay, sorry. There. This is a number 4, 6, 7. We found that one. Then we found 114. Well, I guess, if we're actually already looking over all the lines, we can probably already find the neighbors now as well. Lines to search. Numbers for gear. filter fn actually those aren't numbers, lines to search, those are numbers to search. Numbers to search. Okay, no, I'm just going to do this in one. So I just don't know if that makes any even sense. In adjacent line takes line index and a number and does this stuff. So and in adjacent line, line index, number, and if it is an adjacent line, then we need to find his gear as neighbor. And that would be gear has gear as neighbor, line index, gear index, keys, neighbors, any, no, what was it again? Some neighbor neighbor, and what we need is we need equals number index of neighbor needs to be the gear index. Oh no, am I still in the... Yep. Needs to be the gear index and the number index. Shouldn't have been called number index, should have been called like character index or something like that of neighbor. Oh, sorry, line index. Line index of neighbor should be the line index. And we're gonna do this over all neighbors. Nearest neighboring gear. This is a number that neighbors the gear. .476, and then 35 should be the other one that neighbors the gear. There we go. So they should only have found two. Count. Two. And if we search for the second gear here, then it only finds one neighbor. Cool. So we found the numbers neighboring gear. Now we say if count of numbers neighboring gear is 2, then what we return is times number of first times second, and otherwise we return 0. $16,345. 6,345. Okay. And now we are going to we don't need to reduce here. We are going to apply plus on map partial calculate gear ratio index numbers over all indexed gears. Oh, numbers with neighbors. What is that again? Oh, I did bit. Oh no, this is from the previous one, isn't it? This can go. Confusion. Success. Okay. Well, it was fast at least. Boy, thank goodness. Thank goodness. What, it sucked. Well, I'm just okay. I hated all of that. That was just not fun. That was not fun. Just trying to clean this up a bit before I commit it. Go away. Alright. I'm out of here. See ya in day 4.